live. We are going live in our office room to do some LeetCode problems, or one, and this time it's probably one. It's usually one, but this time it's one because it's a hard level problem. It was on the list of our little LeetCode group where we try to solve problems and algorithmic problems. And this one is, let me share it. So I need to maximum ways. And so it's called maximum number of ways to partition an array. We want to do the following things. I mean, our goal is to solve a problem within 40 minutes. That's like target time, 40 minutes. Would it be like that? We'll see. But I mean, logic, if we could solve the logic within 15 minutes, yeah, that would be good. That would be good. But I mean, let's start small here. Let's try to understand this problem first. So maximum number of ways. This is, hard level. Let's like get startled and like scared and just I don't know. Let's hide under the table a little bit and then come back and see what we can understand. Well, you're given an integer array nums of length n. Wow. Okay, I can understand that. Okay, that part I get. Yeah, so nums is an integer array of length n. I like it. I mean, so it's some kind of in this case, so there is like this array. Then, okay, 2 minus 1, 2. The number of ways to partition nums. Partition. What means partition? Partition with separate. Okay, so to break into, to divide up. Okay, to divide up into like to divide this part and this part. Yeah, okay. Partition is the number of pivot indices that satisfy both conditions. Okay, pivot is at least one, but it's less than n, so it's at best the last index. And also nums 0, nums 1 plus pivot minus 1. Their sum equals to all of starting from pivot 2 till num minus 1 is the last index. Yeah. Okay, so starting from pivot to the net, pivot and to the right has to have the same total sum as everything before it. Okay. So how many points like that? Okay. You're also given an integer k. You can choose to change the value of one element of nums to k or to leave the array unchanged. So there is like n plus 1 variations. Because I mean, n is any of the n, any of the values, and there is n values. It can be changed with k. So you or none, which is n plus 1. which is why it's n plus 1. Can you hear me calling out your name? Can I? Return the maximum possible number of ways to partition nums to satisfy both conditions after changing at most one element. Okay, so here is an example. Yeah, this 2 minus 1, 2, case 3. One optimal approach is to change nums 0 to k. So instead of 2, we have 3. So, and then there is one way to partition. Yeah, 3 minus 1 and 2. So pivot in that case is at index 2. All right. Can you hear me calling out your name? Do 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 do. Zeros gives us 2. Leave it unchanged, and we have this and that. We have 2 and 1. Yeah, we don't have, and pivot has to be at least second, and at max it's the last one. Okay. And then there is nums. There's a longer example, and its output is 4. The optimal approach is to change nums 2 to k. The array becomes this. There is 4 ways to partition the array. Okay, so, and there is like, there is up to 10 to 5 of values. They could be negative. Negative, yeah. Well, if we didn't have this k, yeah, let's break this problem apart and simplify it a little. If we didn't have this k at all, this variations, and only had the array, we would need to just calculate the sum, the full sum of the thing, and then do like this pointers, move the pointer and calculate both sides, and when they're equal, yeah, like this side and that side, we'll count it as a pivot point, pivot index. And that will be an linear solution, big O of n. But we have our k, and for each n, it will be like n by n squared. It becomes n squared, which is not the best. Time complexity. Why? Because it will give us n to 10 to the power of 10. So that's too much. So this brute force will be too long. Okay, let's. Let's see, but that's kind of the brute force. Yeah, just check, take each number. Yes, try without the change and then try it with every change. With changing each number one at a time. Can you hear me calling out your name? No, 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 no. What we want to have is the maximum number of those pivot indices. So, like with this example, if we don't change anything, we will hit, by the way, our secret plan for practicing this is to probably go more than 40 minutes. I guess the max would be, I don't know. Typically, I try to stay within an hour. That's max. So, what? I mean, can we do some kind of? Yeah, if we didn't change here anything, then it's 2, then 1, it's 1, 2. I mean, there is no partitions, no pivots at all. If we change, the last two, then we'll have the same. Yeah, we'll have 3. And this 1, 2. Yeah, we'll have the same number of ways to partition. So there are several questions I have. One is there like a dynamic programming solution? Another is there some kind of reverse logic that we can use to make it much easier? Another idea is, can we use a hash map here somehow? A hash map. Another idea is, so DP or reverse or map or prefix or combination or any combination of those. I need water. I've got so many ideas already. If we make a prefix tree out of this, prefix sum array, can we try those variations? Prefix sum allows you to know the sum of any range, the total sum of any range in constant time. So if we apply this replacement of k. Okay, when we replace k, yeah, because like prefix here, I'm not seeing the prefix solving this. I'll be like 2. Then at this point, it will be like the sum of 2 minus 1 will be 1. And that will be like 1 plus 2, 3. So, yeah, the sum of all these. And the way you know it is, yeah, you can like this range, you know that this point is the sum of this range. And that range, we know that the last value is the total sum minus the previous, the remaining, so it will give us, it will give us that sum. So anyways, but I'm not seeing it how it will help us. I'm not seeing how this will help us, could help us, because we don't have a problem with, I mean, even with the prefix sum, it doesn't immediately tell us the number of partitions. The number of partitions, yeah. Because we need to check, still need to check every value. So yeah, I'm not seeing how that could be helpful. At least at that point. Then what else? What else? Then we have this. Can you hear me calling out your name? Know that I want it, I don't want to say. Come on, baby. Okay, well, any other idea that seems more plausible than others to improve? And by the way, we're already 17 minutes into. And yeah, we're looking for the logic. Hash map. What is, yeah, a hash map could, I don't see this, how, like immediately how it's applicable. Come on, baby, better make a start. Because, I mean, we can store we can store indices. No, I can't see a hash map. I mean, not immediately, okay? So dynamic programming, if we know the solution for the one without replacing, does it tell us something about like this one? Yeah, we know there's 0 without replacing. Then we try replacing. Replacing with K. Replacing with K is essentially a new, so it will give us new sums, and we probably wanna we'll have to compute it again. I mean, it will change just one number. Everything else will stay the same. Right? But I mean, to count partitions, we need to do the comparison again. Okay, now don't see immediately how it's helpful. Okay, now reverse logic. Start from some other end. Let's count this. I mean, what is the possible maximum number of ways to partition? The possible maximum, let's start from that maximum and count back. The possible maximum is 1. Yeah, that's the possible maximum. It's n minus 1, as here. And that's the possible maximum. So can we somehow reduce it? Another way, what if we if we could go replace all of the numbers one by one with K, and in constant time know many partitions, each combinations has, that could be a solution. Right? Right. So what does changing one number change in the whole picture? What it changes is changes that number, and it changes the sum of all the, like in this case, it's 30 minus 33. Changed that number, and it changed the sum of all the ranges that include that number. By a pretty predictable amount. Yeah, if we could know, like, by changing 2 to 3, if we could know immediately how many more it gives, I mean, how that affects, yeah, how it changes number of ways. Okay, we looked at some ideas, but I'm not seeing one that kind of solves it. Okay, what was the other idea? Dynamic programming, reverse logic, hash map, and I don't even remember what it was. Prefix, yeah. Okay, let's look at the constraints again. So it could be a negative value. Another way to look at it. Okay. Let's say we still count the partitions in linear time. Can we count them for each value? Can we also include the combinations of when this value, what if this value is changed? Yeah, replaced by k. Like we'll look at 2, and we don't look at, we can replace by k any. Yeah, but we will look at -1 and any element. And we have the sum of -1 and 2. So for this comparison, we can go and change and do replacements of k with k of elements one by one, and see if that gives us a solution. So yeah, in this case we wouldn't get, but in that case we would. Yeah, we put 3 here, and it will give us a partition, a pivot point. By the way, when we talk about sums of, it reminds us of the prefix sum array. It also, what else does it remind us about? But look, if we were just looking at this value and replaced it, so we would check, that, and then we would check it with only one replacement, not all of the elements. Here, if we just replace that will give us 3 here. Oh, so 3 here and 1 here is not enough. It's not a match. Yes, we looked at this. Yeah, we're trying to play around. Intuitively, I feel like, yeah, if we go, if we're here, and we go like, and we go, let's play around with the hash map. Yeah, hash map, because it could be yeah, we're 30 minutes in looking for a logic solution for that, and it looks like it's probably a good goal for this one. Yeah, to find the logic. Hash map could be what? Hash map could be, actually, we could use like a value, integer, and then its index. Because that, by the way, that allows us to, like, that approach is used to solve the two-sum, because it allows you to immediately know if there is this number and know its index. Yeah, so if we store it in a map, if we stored, let's just simple idea. Simple very thing. We store nums, so we have a num, and we have index, and in our map, and so it will be like that. We'll be like, oh, by the way, they could be repeating, and in this case, hash map will only keep the initial, only keep the unique values. So that's not. What is essentially a sum of these elements? It's a number. Could be negative, could be positive. And we know it by summing them. There is like no other way to know it. You need to go over each number and add it to the to the sum to know it. Add them up to know the sum. Right? Yeah. Yeah, but I mean, when we check the partitions, we don't have to do it for every number. We will deduct the number and add it from the left side and add it to the right part. Yeah. Take it out of the left side, add it to the right side. Well, actually, we'll just, it's a bit different. Yeah, we'll just add the last to the zero, like the previous one to the zero, and deduct it from the total sum. If we were to change one of the values for k, we will need to know the difference and adjust the total sum with that. "35 minutes in." I'm thinking about, let's look at that. So we actually have pins and we also have topics. Let's check the topics first. Array, hash table, counting, enumeration, prefix sum. Yeah, so it looks like we did find the prefix sum. How do we use still? Yeah, so the prefix sum seems to be a topic here. And the question is, how would we use it? The prefix sum allows you to know for each index. It will allow you to know the sum of those values. But what does it allow us to do in this case? In this case, knowing in constant time, knowing the sum of values. If we can use some memory, with I do feel like some combination of the hash map and prefix sum could be helpful here. prefix sum, as we said, it's basically this, yeah. It's going to be 2, 1, 3. So can we somehow use prefix sum with alternatives, those variations when we change a number? But that seems to be many variations does it create? Yeah, I mean, if we change that to 3, well, how will it change the prefix sum? If nums is 3 minus 1 and 2, the pref will be 3 2 4. Right? Right. That will be it. But so basically changes all the values in the prefix sum by that difference between that number. There is this offset, just like +1, +1, +1, +1, which is just natural. And then, but then prefix sum, when we'll look at the number 2, we know that at 2, know that 2 is the sum of all these. And we know that 2 we know that that is the sum of all these to the left, including it. If we want to know the sum of all to the right, we need to deduct 4 minus 2. Okay, there is a way to know that immediately, but what it looks like that it just changes the entire prefix sum by the difference between and we're approaching 45 minutes looking for the logic. And my intuition suggests to look up the hints. I'm pretty sure we'll be just following our initial ideas, like one by one. Now, I have this feeling. Yeah, the prefix and suffix, yeah. Yeah, we got that. That's what we considered as well. Yeah, how the prefix and suffix will change. And we know, the prefix will be increased. The suffix will not. It depends on which I, but in this case, yeah. It depends on where it is. If it's in this, it will change by the difference, yeah. Change the prefix in this. If it's within that range, yeah, so basically we don't care about which, well, we just need to, we need the value. We need the value that has the difference. Need the value. If we can knowing k, we can calculate the difference that we need. Like if we want to get this specific suffix, yeah, knowing k, so basically, yeah, we can know. So we can, if we change that specific k, yeah, we can, using set map with indices, we can figure out, like, is there a value that will give us the difference? Yeah. Okay. And when sweeping through each element, can you find the total number of pivots? Total number of pivots where the difference of prefix and suffix happens to be equal to the changes of k That's where the difference yeah, so can you find the total number of pivots where the difference of prefix and suffix happens to equal? Yeah, so when we can get the difference, to know how many total number of pivots where the difference of prefix and suffix happens to equal. Okay, to equal. Yeah, to that difference between K and I. Well, we can keep in the map number of, like, let's say we'll keep in the map the number of 2's. And we'll know, okay, there is 2's, there is 2 of them. All right. So it's been 15 minutes, and I think let's have a little bit of summary. So far, it looks like we did figure out the directions. That it's prefix and that it's a map, hash map. Yeah. And that, and also how it affects. We were looking at how it affects the full prefix tree, prefix summary. Yeah. We're comparing prefix and suffix. Yeah, so what I like is that we did know the directions where to go. Yeah, intuitively. It's a bit more tricky to like intuitively figure this out. I mean, we were pretty close. If I was thinking also in this prefix and suffix logic, that we are comparing them, yeah, it's still a little bit tricky. But that's good news. The bad news is that, yeah, it's still a bit tricky, even with knowing what kind of, or having the cues. I mean, having those figured out, the directions. It's still a bit tricky to kind of connect the dots. Okay, how to use them and like see how to implement it. I mean, how to and it's so that we solve it. And it seems like there is a linear time solution. Yeah. So this, as a summary, I would say it's been a good exercise to try a harder level problem. We came up with the right tools, and we just need to dig a little further to connect, to find the missing pieces. The missing piece was it looks like, was to see what would help here, the missing piece, was to draw this suffix, prefix, pair it with postfix suffix. That gave if we'll look at it that way, and then total number of pivots where the difference for this specific each element. Can you find the total number of pivots where the difference can you find the total number of pivots? Happens. Can you find the total number of pivots? So what that means is total number of pivots where difference of prefix and suffix happens to equal to the changes of I want to be with you everywhere. Okay, so I will need to think about it. So in summary, good exercise, good, found the right tools and got pretty close to it. We got pretty close, yeah. So that's our practice for this problem. And thank you for watching. And we'll see you in the next video.